Given the equation of a curve y equals 8x minus x squared, express 8x minus x squared in the form of a minus quantity x plus b squared, stating the numerical values for a and b. Okay, so first thing we're going to do is I'm just going to rewrite 8x minus x squared, and I'm just going to kind of readjust this in ways I feel more comfortable. So I'll start by saying that y equals negative x squared plus 8, just rearranging the x. Pull out the minus, so we got minus y equals x squared minus 8x. And now from this point, it's kind of more evident that what we want to do here is complete the square. So to complete the square, the idea here is we want to add some number here and then subtract the same number off over here. That's not supposed to be an x. There we go. Some number. And you can kind of do it through guess and check or feels, but the more methodical, correct way of doing it is you're going to take this number right here, this negative 8, divided by 2, and then square it. So if we do that, we're going to say that negative y equals x squared minus 8x minus 8x. Negative 8 divided by 2 is negative 4, and squared will be 16, so we'll add 16 and subtract 16. There's two things you can always do in math. One is add 0, the other is multiply by 1. And this is effectively adding 0 here. 16 minus 16, 0. So what we're adding here is 0. You can always do that in math, pretty much always. So now that we got our terms here, we're going to readjust this a little bit. If you look at this, you can tell that this is x plus x minus 4 squared minus 16. And if you don't have faith in my math or your math or math in general, well, okay, maybe you have to have faith in math in general. You can then FOIL this out. X minus 4, x minus 4, x squared. You get 2 negative 4 x's, and then you have plus 16. It's like, oh, yep, that seems to be reasonable. And this is the concept of called completing the square. All right, taking it one step further, we'll say move it back to y. Oop, get rid of these guys and that one. Y equals, we'll stick with green. Multiplying by everything by negative 1, we have 16 minus quantity x minus 4 squared. Not too bad. Not too bad. So this is going to be just to kind of look at it real quick, this is going to be a parabola. So it will probably be 4 to the right and then 16 up, and then it'll be pointing downward, like so. Okay, so we've rewritten it in terms of a and b, where a, in this case, was 16, and b was negative 4. So hence, or otherwise, find the coordinates of the stationary point of the curve. So I'm going to call the stationary point to be the max or min, that point right there where it's flat. So we'll say that dy dx equals, and I could probably actually use this one up here, might be easier. So we'll say dy dx equals 8 minus 2x, which we'll set equal to 0. And so then we would have 2x equals 8, x equals 4. So 4 will be our stationary point, i.e. where the derivative equals 0. X equals 4. This one, 16, negative 4. And that looks, there we go. Find the set of values of x for which y is greater than or equal to negative 20. Okay, so this is where completing the square comes in handy. So now we have this equation right here, and we can say that y equals, we'll say 16 minus x minus 4 quantity squared, and we have negative 20. So we'll do negative 20 over here is less than or equal to y, where y equals 16 minus x minus 4 quantity squared. Start by moving the 16 over, minus 16 from both sides, we have minus 36. Keep the inequality the same direction, x minus 4 quantity squared, multiply by multiply by negative 1, which will flip the inequality. So we'll have 36 is less than or equal to x minus 4 squared. Whenever you multiply or divide by a negative number, you flip the inequality symbol. You actually do the same thing when it's equals. It's just that equals is the same on both sides, so you don't notice that it's flipped. So continuing on, we take the square root of both sides, and to do this, we'll say 36 is less than or equal to, oh, nope, we need to do a 6 there. Good call. 6 less than or equal to x minus 4, but also 6 is greater than or equal to negative x minus 4. This one will divide both sides by negative 1, so we have negative 6, flip the inequality, x minus 4. Solving this, we have, let's see, add 4 to both sides. 10 is less than or equal to, is greater than or equal to x. And on this side, we have, add 4 to both sides, so we have negative 2, less than or equal to x. And so that kind of gives us this range right here of negative 2 to 10, where x is between negative 2 and 10. That's not too bad. So we look at this part, so right here, negative 20, like this. That's going to be negative 2. And that point is going to be 10. Pretty good, pretty good. State the domain. Okay, the function g is defined by g such that x is 8x minus x squared for x greater than or equal to 4. So I'm going to say, clean off a little bit of this real quick. There we go. Perfect. So what I'm going to say here is g of x equals 8x minus x squared for x greater than or equal to 4. So our first part is we want to state the domain of inverse of x. Ooh. Okay. So I'm going to say y equals g of x. Just kind of, my notation is going to be terrible here, and I apologize. But this is kind of how y equals this. To find the inverse, I'm going to swap the x and the y. So I say x equals 8y minus y squared. Solving that using the completing the square, we already know that it's going to be something like y minus 4 squared. Rearranging this in terms of y, we will now have x minus 16 equals negative y minus 4 quantity squared, square rooting both sides. We have y minus 4 equals square root of, let's see here, this would be 16 minus x. And then we would also have negative quantity y minus 4 equals square root of 16 minus x. Looking at this one real quick, this would be the same as 4 minus y equals square root of 16 minus x. And y equals square root 16 minus x. Minus 4. So we have, multiply everything by negative 1. We have 4 plus 16 minus x square rooted. And this is y, which is the g inverse of x, because I swapped the x and the y's. So this y equals g of x, but then as soon as I swapped it, y was g inverse of x. And so one of our answers then is 4 plus 16 of x. And then when we do it the other way, with this one over here, we get something similar. Y equals 4, wait a sec, at 4 plus 16 minus x. I think I forgot a negative in there. Yep, that was supposed to be negative. There we go. Square root of x. Long story short, g inverse of x equals 4 plus or minus 16 minus x square rooted. And I think this actually answered. So we go back to what we're actually trying to answer here. Find an expression in terms of x for g inverse of x. So that part is done. That's what this is right here. And now it's easier to see what the domain and range would be. So the domain is whatever x can equal. So x can equal, so x is going to have to be at least 4. So we can go, x can be from 4 to 16. Because if we got up to 16 here, then we'd start trying to take the square root of a negative. So that's impossible. So 4 to 16 is the domain of x. So it would be written something like 4 to 16 inclusive. And so then the range would be, so I said the range of inverse of x. Yep, domain range of inverse of x. So the range then would be, well, we could plug in 4 here. So we get 4 plus or minus square root of 12. So that would give us 4 plus or minus 2 times the square root of 3. That seems reasonable. And then we would have from there, if we plugged in 16, we get 4 plus or minus 0, which would be 4. So since 4 is right in the middle of 4 plus or minus 2 square root of 3, for me, I think the range is what y can be, how far it can go, would be 4 plus or minus 2 square root of 3, and that would be the range of inverse g inverse of x. So that's how I would approach this problem. Really easy to get tricked up on all these things, especially the inequalities and making sure when you're dividing by a negative number or multiplying by a negative number, you have to swap the inequality. And then just lots of other small nuances that to try and keep track of. So I hope that helped. See you next time.